So this project, the idea is if you have some kind of flexible antenna array, as it deforms, the beam pattern is going to change from desired to kind of an undesirable pattern. And our goal is to measure that deformation in real time and correct the beam pattern as we go. Adam, first of all, can you tell us a little bit about where you come from and how you ended up here at EMA?
I'm a student at Northwestern University. I'm a rising junior, and I'm majoring in electrical engineering.
Yeah, and I remember when you first came in, Tim told me, like, you're going to really be impressed by this guy. And I was like, yeah, whatever. You came in, and I was like, okay, I get it now. So I'm glad you came back for summer. So now you're back here, and you've been working on several projects, but I think we'd like to talk a little bit about the array metrology project. Can you tell me a little bit about your experience in working with this project?
Yeah, so I've had the opportunity to work on multiple different aspects of this project, all of which have been very interesting to me. One of them is, for example, implementing the actual correction algorithm. So I was given this kind of formula to work with. Okay, if it's bending this much or deformed this much, you need to do this to correct for it electrically. So I implemented a script in Python to be able to calculate those corrections, and over time kind of optimized it for speed to be able to work at the necessary frequency. Additionally, I've also been tasked with working on a control algorithm, particularly using a PID controller. Because this antenna is going to be vibrating, just constantly changing shape, we decided it was of potential interest to have such a control algorithm to be able to adapt to continuously changing conditions. We've been developing prototypes and testing out smaller versions of what the actual product is going to be. And I've also had a role in that, both designing and optimizing our prototypes and also constructing them.
Yeah, so you've actually been building physical antennas to test.
Yes.
Now, there aren't many rising juniors that would say that they've been able to do that. So that's super impressive.